we have to start right away. First of all, who are ready? Anyone? Any team? Who is ready? We can start. Are you ready? Yeah, okay. And any other team? It's not yet? If you want to, you can upload your file to the Google Drive, then you can log in. That is the easiest way. So you can use the incognito window, then log in. Please upload the file to the Google Drive, then we can start.
We can go first.
Oh yeah,
Yeah.
you can start. It will not be saved. Your password will not be saved
Okay.
once you close.
We added it last second.
Yeah, put the relational expressions in there too, so that you could explain like.
Should we put up our actual, what we turned in for our 1 and 2?
It doesn't matter. You can use the PowerPoint. You can use the actual file. So it's up to you. But I'd like to see the design of your database. Okay, you can start.
So for our database, we're doing a card bidding system.
Okay.
So a basic overview, we're going to have an interactive website for users. There's going to be numerous different features for the auction system. It's going to be suitable for both bidders and sellers. So bidders will be able to find the used car of their dreams, and sellers will be able to get the amount that they want for the car. There's specific features that we will be including as far as filtering results by user-defined specifications, marking cars that they're interested in watching, so this is for the bidder as well. And then they can also have the option to skip the auction process altogether. If they have a bid that the seller also agrees on, they can skip the auction process and just purchase the car. And then as far as sellers, one feature that we're trying to include is they can set a base price for the car, so the bidder can't bid below that base
So
price.
basically your system is the web-based application, and as a backend, you are going to access the database.
Yes. So this is our enhanced entity relationship diagram. I know it's kind of hard to read, so I'll just explain some of the major points. We have two super subclass relationships. One of them is item features, which is the...
You have printer? Okay.
Yeah.
The middle one, red one?
So this is item,
Okay.
and then item features right here.
Item means a car?
Yeah, so it's
Okay.
gonna, item is like a vehicle in general, and then so item features is basically the basic or standard attributes for all vehicles, and then we have a disjointed
Different types of cars?
class. Yeah, so we have cars, trucks, SUVs, and sports cars. And one like specific attribute of just trucks is either like the size of the bed of the truck or the tonnage of the truck. So that's why we did a super and subclass for that. But it could be disjointed because a vehicle can't be a car and a truck. The other super subclass we have is users, which is over here. And a user has an overlay of admin, seller, and bidders, because one person can be one, two, or all of them. And then each user, admin, seller, and bidder, has their unique admin ID, seller ID, or bidder ID. And then, in addition, a seller has specific cars, so they have hidden cars and they have visible cars. We also have strong and weak entities. So one example of a weak entity is over here, payment information. So that's not required when a bidder signs up. So it's not necessary until they make a payment. We also have mandatory and optional relationships. So one mandatory relationship is that a payment, and you can see the double line, must have payment information because otherwise the order can't be processed. And then an example of an optional relationship would be the bidder placing an order. So this right here, see here. Because in every case, a bidder might not place an order on a car that they see.
So where is the bidding information from user? So user is there, so as a bidder, I direct to
Yeah.
bid on item. So how
So a bidder
how they are related?
bids on the item, and they also place orders.
Place order means the place in bid.
Yes.
Okay.
Yes. And then we also have relationships with attributes. So if you see this one right here, it manages. So an admin will manage items in the database, but the manage has two different attributes, modification type and modification date, so we can keep track of the changes that the admin makes.
So you allow the multiple bidding?
Yes.
Okay. So you need to clarify how can you identify the bid, different bid, because it's a multiple bid. And also the admin should it depends on your requirement. So one example is as admin, the manually decide the highest bidder.
Okay.
So then there might be relationship, or it can be automatic. So you can always select the highest amount bid as a winner. Like that.
And then, so this is our relational model, and it basically diagrams the enhanced entity relation model. But one thing to note is for our users, we've modeled it using option 3 because the cases overlap, because you can one user can be multiple different things, admin, seller, or bidder. So you can see at the end here we have the user type, and it could be either admin with these attributes, bidder, or seller with these attributes. And then for the other super subclass relation item features, we did it using option 4 because it's a disjointed case, and the item feature can be only one item. So here you have all of the different entities and attributes. So you can see here all of the arrows, the functional dependencies of each entity itself. And then using this relational model, we've created queries and relational algebra expressions.
So here are some of the examples of the queries that we did. So for one, there's to retrieve salad product descriptions of the item, whose product is ID. So as you can see, you select it from seller production description, and you get it from the item, which I believe is the superclass, and you get it for the product key. No, what was it called? PK? Primary key, which is the product ID. And on the bottom, underneath, you'll see the what do you call this? Relational algebra right here. And then the second one, you can see retrieve make model of the items whose bid number is. You can just pick up anything, and then you get it for select. You see here. I just followed the. I got it from the book.
You already did.
Select from where. I don't know if I did it right, but
Okay.
yes.
After we cover the RA, so it's not a big deal.
And that's what we got. That's pretty much it.
Okay, very nice. I think the very nice. And one is kind of pro tip. So why don't you go back to the ER diagram? Actually, we don't use a lot relational schema diagram. We don't use. Instead, we have kind of right now most of the project use the tool to keep such a relational schema instead of drawing the schema diagram. But the relational ER diagram, so even though you are using the tool, so there are different notation. So depending on how you organize, like the drag and drop, it can be very hard, sometimes easy. So one of the popular approach is the top left corner, you can put the most important schema or entity. Like for example, in this case, probably the B related one, B, or transaction, such as the most the related, the point related or the relationship related, the schema top left corner, then it's kind of branch like this. Okay. Another approach is the most important one in the middle. Yeah. So it's like the star schema diagram. So we have the main, and you can put this way. So then it's easy to understand over your schema. Or the ER diagram. Okay, very nice, nicely done. Thank you. But think about the more interesting, the relational algebra expression based on your requirement. Okay. So I think you showed only 2 examples.
Yeah.
But think about the more interesting. Next Tim. Yes. Actually, car building is the most popular one. So but even some of the students are struggling to create design the table or entity for the car itself. So it's not that really simple. So you can simplify. There are not too much details of the option for the car vehicle. You can click the 3 dot right hand side. Yes. Then the third one, new incognito. Okay, not this one. Third one, yes. Nowadays, most of the public school, private school in US, as far as I guess, so 80–90% of them, they are using the Google Classroom. So using the Google Drive, everything. So all the homework and presentation, everything through the Google Drive. You can just present. So because you upload the file, it doesn't present. Yeah, if you want, you can download. Yeah, so you can import if you are using the Google Drive slide. Okay, go ahead. Don't worry. So go ahead.
So good morning guys, my name is Shivsai Karne and my name is Pranjal. So our project is like work from home. The name itself just says that you can work from home, that's it. So in our project we do have so first of all, our project is like a platform in order to get communication between the recruiter and also employees. So many people faces difficulty in order to search any jobs, and moreover they do the jobs which are like out of their qualifications. So in our website it will become like platform in order to search a job which you are really interested, and also the kind of jobs which just suggested like your background. So
who will be? Company or you?
no, it's like we do have recruiter and employer. Recruiter will place the job which has to be done by these employees. So employer will the bid for those jobs. So the recruiter will
be. So I can work for it's less will be winner, right?
Yeah.
Doesn't look like so the humanity, right? So it's kind of selling to my work.
That's how our contractors work.
Moreover, when you just
I think the opposite might be reasonable. So for example, so I can work. Somebody can buy the skill or time, right? But it depends on the market situation. Go ahead. Interesting.
So moreover, the additional information, I mean, the additional new feature we have added in our project is like, you can make, like, you can form a group between your employees, and there will be like group bidding system. Because whenever a recruiter places a job which is like a heavy budget, and he don't require one employee. He might require like n number of employees in order to work to be done in certain period of time. So that's why the group bidding also is there in our project. So this is our ER diagram where we do have first we do have a user like employee, recruiter, and admin. Admin can watch. I mean, admin can just watch everyone over here, and we just created the UID which is so unique for every employee and every recruiter, and also admin do watch the employees and recruiter by using their UID. So that we do have.
So admin manage the whole their
all
process,
the,
and there are two groups, like the employee and the recruiter. So employee will bid for the job.
Yeah.
Okay.
So moreover, if there are like some fake profiles, like any fake, qualification of the employee, then the admin will take care of those also. So we do have so many relationships and so many entities. For employee, we do have skills and
Can
rating.
you
Which means
the whole list of relationship, because it's hard to read. What's the first one?
here from here.
Between the employees and
This is first payment, work, feedback, bid, groups, pay details. This is job and bidding. So basically, our website is to create a profile for any user. For employee, the profile will be they need to add about their skills and their qualification and the past work which has been done. And moreover, there will be the ratings which is given by the recruiter to them. If they have already done one work which is assigned from any recruiter, then the rating will be present for employee. So the first,
this is not the relationship. This is the entity. Then you create the relationship. Oh, I see. Okay.
Yeah, it's like he can add
okay.
himself the rating,
Yeah.
which he's received. So let me just explain. So first recruiter will be like recruiter type, which means there will be like so many recruiter jobs. For example, the recruiters will be, the background of recruiter job will be like mechanical, electronics, and electrical. So this is like type for recruiter, and recruiter will place the job. And these jobs can also view by the employee so that they can able to see what kind of job is that. And for job, we do have the job ID and job description and job type, what is the type of the job, so that the employee can able to see easily. So then we do have like for every job we do have one bidding. So the recruiter will place the minimum amount of the bidding and also the start time, the end time, and the period of the work which should be done. So next, the employee can bid for any job, and the bid contains. The bid contains what employee should add. If I am going to bid for a job, so what what information I need to provide for recruiter in order to get accepted for my bid. So those information will be like the time period which I want to complete your job. It's not time period which recruiter will place for the job. For example, recruiter will place a job which should be done within like 7 days, like 7 days. But I am an employee, I'm so efficient employee so that I can complete that work in like 5 days. So even that I can mention for the recruiter in order to make like some good impression.
Okay, so I think pretty much enough. Then this is one of the examples. Some of the it depends, but you can see there are a lot of
So this is like group bidding one.
Entity between the employee and recruiter, that makes sense. But you can use either the many-to-many relationship or this one. It depends. So, but sometimes it's hard to understand such a relationship. So I'm not saying the many-to-many is always good, but sometimes it's hard to understand.
So that's why we used all, we used 1:2 everything.
Yeah, one-to-many entity. That can be actually the many-to-many that may be easier to understand sometimes. So that's the first time that it looks like something relationship or like that. Okay, go ahead.
So this is
I think that's pretty much enough for the ER diagram.
so she will explain.
Based on the ER diagram, we created a relational schema. So, based on this relational schema, we are going to design our database in which we have employee in which we have UID, date of birth, and all those things. Like then we have recruiter, admin, job. So, the employee which will the recruiter will assign a job to the employee, and that is.
You can use keyboard or use slide to show. Bottom. Yes. Yes.
Okay. When the employee get a job, the job ID is stored over here. If the employee is present in some of the group, then the employee will have a GID, and the payment details is stored in the PID. Again, if recruiter will place a job, like recruiter will give a job, like it will. So the job ID is given for the recruiter also, payment ID, and then we like pretty much. How I'm not getting how to explain because already you explained a lot.
Okay,
I'm
it's
trying to
okay. So
explain,
we got the idea
Yeah.
of that design. So you don't have to spend a lot of time.
Yeah.
But my question is, when you create the relational schema diagram, mostly the name of the relation, name of attribute will be eventually table name and the column name. So you should be careful this
Okay.
time. The two names. For example, bidding and the bid in the middle. So
Yeah.
it's not easy for others to understand the difference, the bid and the bidding. So you can clarify when you name it. And also, if you have, for example, the bid, it looks like that is the composite primary key combining the three one. So I didn't explain detail. Probably I will mention about that later. I did a couple of times the surrogate key. So if you have the something ID plus something attribute plus attribute as a primary key because of weak entity or the other relationship, so at the time you can create something deep ID or we already have the PID, so you can name differently.
And
Create
add
the,
all the composite key in that.
you can create the one primary key, something ID or sequence number. So looks like the bid has only bid information, but bidding is the kind of transaction, right? Am I correct? Or vice versa?
So the bid is like for one employee, the information which he want to give for the bid. And the bidding will be like for entire,
Activity.
for a job
Yeah.
for entire, I mean entire information for
So you
all
can
the
name
employees.
differently, then it will be better to understand. Then at that time you can create, if you need it, you can create the surrogate key that combine the composite key. Okay, so next.
Next, these are some of the query which will be like recruiter can search employee based on a rating. Like the recruiter can search like I want the employees, I want to search the employees which have, the employees will have rating than 4, above than 4. The recruiter can search the employee. Recruiter can search the payment amount, like if recruiter want to see that what payment I have made earlier which is greater than $100 or $200, this can be, this query can be fired. Then recruiter can search employee based on skill and particular rating. If the recruiter wants, like I want a programmer which knows C++ and his rating should be greater than 3, then recruiter can search based on that criteria.
I think it's also a good idea. It's not like an eBay system, so you cannot select the employee as the lowest bidder. So as an employee, because you need to consider other skill. So like if I bid, I do not know anything about the program, but bid like $1 per hour, it will be selected. So you can give the recruiter the finalize. So you can recruiter retrieve the candidate by providing option, then select the finance. The B.
Because that makes a difference when the both employees will bid on the same amount.
Mm.
So the recruiter will,
At that
go
time,
detailed
yeah.
information for what they provided, like basically.
Then employee can search on the jobs which are based on like any employee wants the job of higher budget, like then he can search on that, and employee can search job on like I want to search a job for a Python programming. Then employee will search that job and bid on that job, and that's it. These are the some of the queries
Sure.
we have in
Yeah. I think the design probably okay, but a little bit touch for the relational schema diagram and name and the ID, because you are going to use SEDs to create the database. Not SEDs, but it will be the kind of the guideline. Did you think about the application to implement this? Python and web?
web.
Okay. Okay, very nice. So next. Yeah, go ahead. Close the incognito window. Black one. Just close this one. Any limitation of a Google Drive for UB student account? Or unlimited?
Some, but it's very abstract stuff. Like everything that I use on there's nothing I use on my personal account that I can't access on my school account. So,
What is the CND? It's a CD-ROM?
no. So the title of our database project is C&D Books. The
Initial?
They're the initials of
Ah,
our
okay.
first names, so it's just kind of our catchy name. We're building a book bidding system where users can submit books and bid on books at the same time.
Yeah, so usually the issue with running a bookstore is that things get confusing. You don't know what book is in stock or what book is out of stock, or how many customers you have, and you're also selling the books online, so we have to keep track of that. So we are just going to try to make a database to give the solution to that problem.
So the solution is that a database would be the best solution to manage all the information that goes into such a bidding system, because there's a lot of information that needs to be stored.
Just an overview of our ER diagram. When we come to implement the database, we'll understand more and maybe implement more entities or change names and things like that. That's just a very broad overview.
Which software did you use?
I use Irwin to.
So this is a typical diagram notation that you are going to see in the
Yeah, I couldn't get it to show the cardinality for some reason. I really.
But inside there is so sometimes some of the project manager like if you add the entity, it's automatically connect the database, then create the table, even the considering cardinality, right?
Oh.
So that shows the cardinality actually many to one and dot, so based on the UML notation.
The dot.
Yes.
Yeah, I was about to ask if this is used.
Mm.
So this is our relational model. It's organized from our ER diagram, and then it's put in so that it has all the proper connections so that everything connects to the next part.
When I was administrator, we create the 1 page per table. So it has something, the template, like the name, primary key, and the candidate key, even foreign key, any constraint. So one page per cell. Sometimes I have the paper to represent the 2,000, 3,000 table. Then I need to look up everything. It's not databases, but even we don't use such a the relational schema diagram instead from the ER diagram. So there are software to manage the project.
Sounds like you would need a database to manage all that.
Yeah, so there is really. So there are the nowadays the audit, the who actually verify whether this primary key will be allowed or not, something like that. So they have their own database, full database. So.
Now, lastly, this is an example of it being selected with the SQL language. Just examples of things being selected from each and every entity or attribute, just random things.
Okay. So I think that you guys, based on your requirement, probably your relational algebra and the eventually SQL will be more complex.
Yeah.
Okay. So think about the more interesting stuff. Okay. And also, did you think about how to implement eventually, like the web application or standalone system,
We
any
can do
other
a standalone system. using
standalone
Java.
system with Java?
Yeah,
Okay.
because we're not familiar with web design.
Okay. Also, if you, okay, okay. Go ahead. The next, yes. Benjamin here? No? Divya, you can ask a question if you have. Can you keep your Bridgeport account after graduation? My.bridgeport.edu or this one? You can keep it the same account.
We've chosen the topic of UB book bidding system as the topic for our project. Just the gist of the project is we have a web application to handle the selling, bidding, and buying of books. Here, the UB students will be the normal users where they can be the sellers and the bidders, and the UB management would be the admin. The students will be able to register and log into the system. UB management can manage the entire system and also can be able to access the daily and weekly reports. The sellers, the gist of how it works is the seller, when he or she posts a book, can set a base price and a due date before which a winner would be decided. And the bidder can place a bid on this book if he likes it or not. And actually the base price would be increased by $1. That means new base amount would be set. The next bidder who views the book can view the new base amount. So he has to play, if he wants that book for that base amount, he could place a bid. And before that due date, whoever is the winner, whoever has chosen that base amount would be considered as the winner. And then henceforth can choose the payment system, which is offline, and then go ahead with the shipping system.
So I think this semester I did not receive any question regarding to such a payment or shipping. So you can assume the payment and the shipment will be the kind of offline, or there is a third party. So you don't have to connect or just assume. So you have the shipping, the label, so or the tracking number. So you can automatically generate random number like that. You can assume that is the assumption of your system.
we've also assumed that there would be a tracking number generated for shipping which could be tracked.
I think that if I remember correctly, there was one team before who actually connect the payment system. So you can create I think that there are several websites for payment, but you need to pay like the 1%, 2% would be, but you don't have to in this project. Okay, go ahead.
Hello, I'm Tejasai. I'm going to explain about this ER diagram. As she explained, we have the admins and normal user. We have generalized that into a user, and this user will have all the attributes of admin and normal user. And this normal user will be a user once he registers, and then email verification is happened, and then he can log into the system. And that user can be a seller and a bidder. And if you see that, that's an overlapping because a person can even buy a book or sell a book. And a seller can post an advertisement on the book. So that seller and book are related with the post, and so that each book is posted by only one user, and each seller can post many books. So the relation is 1:1. And in the same way, each bidder can view many books, and each book can be viewed by many bidders. So it is a misprint. In that way, we have connected the seller and bidder with many such entities, and the main ones are the bidder can view any number of books, and as she explained, when a user is bidding a book, a new base price will be set, and that is added here to the bid, because that's an misprint relationship, and then attribute has been added there.
Any reason you create a subclass of the bidder as a winner? The winner looks like the subclass of the bidder, right?
Yeah.
Is there any reason?
Any bidder can be there.
Yeah, because bidder can bid any number of books, but there will be only one winner based upon the due date, and if that winner is there with the highest base amount, then he will be a winner. So we have segregated it into two parts so that it will be useful in relating the payment system, shipping system, and each and everything. And coming to the shipping system, once the winner makes a payment, winner will initiate a payment, and then seller will receive a payment. This winner can choose the shipping system. It can either be offline or online, because it doesn't have any unique key. It is a weak entity, and because the foreign key relationships are seller and winner. And even suppose if the same seller is selling two books to the same user, in that case unique keys will be the same. So in this case we have created a surrogate key to the shipping system. And the admin manages the entire system. So we have created an entity for the system, and that system is related to all the entities like shipping system, payment system, and books, profile, many things. And each user can view other profiles as well. So we have created one more entity profile. Coming to the relational schema diagram.
Please use the software. So right for the next page, so you may change the ER diagram. So we need another entity. You find that it's really hard to devise the ER diagram.
But the admin model is not looking that easy to understand. So we have
This is software. Okay, you guys can do it. It's a software. It's nothing special. So try to get used. This is just to getting used. Okay. So if you add the entity in the middle, it will be really hard to changing the diagram.
Because the users, admin and normal user are, everything is a subclass, and then we have created the option 2 kind of thing. User will have the basic details, and then admin will have number of reports, so that he'll.
Okay, I think that's pretty much okay to conclude. Yeah, I think that is okay. So, conclusion.
So in conclusion, from the basic thing like collecting the information with a problem statement and then extracting the data, we have tried to create ER diagram, and then EER using the relational model. We are now trying to create a database system. I think we have also used this relational algebra, but we couldn't include it in the slide. But we have created few other queries and then included it in the project phase.
Okay, very nice. Thank you. page 3. Page 3, so you are going to create your database. So you already have the MySQL database. So I already discussed with Divya during the exercise lab and the project. You can select either AWS or the GCP for your database. But the database is a MySQL database, so it doesn't matter. It depends on the system. If you want to use something, the AWS service, the REST Beanstalk, or the service, so you can select the AWS. Or if you want to use the app engine provided by the Google for the application server like the Django, so you can use the AWS or the GCP. It's up to you, it's your decision. But you should use the MySQL database on the cloud service, okay? Not your local machine. For your implementation, testing, training, so you can use you can install your own, but for your final project, it should be running on the GCP. And also your applications, if you have the application server or the standalone system, they should be running on the GCP. It may be possible you can connect the MySQL database, AWS, but your application server or application in the GCP and connect is possible, but maybe it's harder. So it's better to use the same service. So please think about such an application part for the implementation. Also, it's also a good idea why we are covering the next few weeks. So we will learn how to use the SQL, and after we complete the relational algebra, while we are covering some of the topic in the SQL and the exercise lab, so you guys can start to create your own database. Okay? So it's also a good idea to create and delete, create again, and see what's going on. Okay, and also probably you may have the more idea and better idea while you are doing the page 1 and 2 regarding your requirement. Always, you can go back to your page 1, the problem definition, and change it anytime. However, when you change your problem or your requirement, consequently, your ER diagram and relational schema diagram will be revised. Then finally you can have your own database. So I know it's kind of practice. So you can, even after you create your database, I need this column, but you don't change anything, ER diagram. It will not be happen in the real project. In the real project, you should get the permission, or sometimes you should go through the audit department to add even one column, because they may affect something security issue or the performance issues. So always go back to at least the ER diagram should be changed, and the relational schema diagram change it. Then finally you can revise the table or add or delete whatever. Okay, so very nicely done, and continue to work for the page 3. There are several things, minor things you will encounter. Before I forgot, the first one thing is a lot of teams will eventually use such a surrogate key as the customer ID or the number or such a thing as a primary key. So because it's a primary key, so it should be unique. The problem is how to create such a number, unique key. It's called the sequence number, generating the sequence number. It looks like the simple, but not always simple. There are different approaches. So in your application, you need to consider such a thing. First approach is a lot of time is starting from the 1 and next 2, 3. It's generating the next number. However, how do we know what is the next number? You need to check the last one, okay? And plus 1, what next number? So which means always you need to access the what if, this one. Even though this is a primary key, if we have the billions of the customer, it will take a time to find even the next sequence number. Okay? So first, if your database is small, you can always check the last number. Okay? How can you check the last number? We will see the select using order by. then the descending order, and you can take the first one. However, that require kind of a sorting and accessing the index. So if you believe that make the system slow or the takes of time, a lot of the project, they manage the sequence number table at the table. So what is the last number? For example, this one is a customer table. Customer table, last number is the 100. Okay? And the bidding table, last number is the 101. So while you are generating the next sequence number, access this table and this column and get this one and update and access it. So this way is popular in the project. However, still the problem is, what if the last one is 100, I select the 101, and while we are doing the something transaction regarding to 101, this transaction is terminated. Okay, then 101 will not be used. And then while the 101 transaction is running, there is another transaction 102. So next one is 102, but this one is terminated. So 100. Then skip the number 102. Whether you are going to allow this kind of skip the number or not. So mostly allow. Otherwise, you need to lock entire table until this transaction is done or terminated. Okay? So this is up to you, but it's not critical. But some of the projects are really critical. Because of this reason, depending on the DBMS, so they provide something database object to create the sequence number. For example, Oracle provide sequence. You can create the sequence. So for example, customer ID sequence. So whenever you access this database object, next number will be returned. It's not real table, but it will return. So database actually implement the entire this kind of process. So you can get the next sequence number. So that has the same issue, whether you are going to skip the number or the lock the table and so on. That's what you guys decide. So nowadays, a lot of them use timestamp as a part of the ID number. Okay? Then we can avoid any duplicate data, because the precision of time is the millions second. So we can use such a timestamp as a part of the sequence number. Okay. So always the sequence number, such as ID, is not that simple. So it may affect your performance. Okay, let's continue the relational algebra. Hopefully we can finish. So for your reminder, we have learned the relational algebra operation. So for the unary operation, so we learned the sigma. Sigma, actually we can access the data by tuple. So this is a sigma. So we can actually filter using the condition. So using condition for the relation, we can access the tuple with the condition. On the other hand, we can access the data by attribute. So this is the projection. So using the list of the attribute, so we can access the data in this way. Finally, if we combine this one and this one, projection and the selection, we can access the data what we want. This is a very basic operation used in the relational algebra. And also we can rename this relation. This is a relation, so we can rename it. And also we can rename an attribute as an alias. So these are the unary operation. Plus we have use the union intersection difference as a set operation, also Cartesian product. If we combine the Cartesian product with the selection operation, this will be the join operation. So join operation actually the most important, the relational algebra operation to combine a number of the relation, number of a table. Later we will talk about what is a good database design. What is the bad database design? At that time we are going to use the normalization. Normalization means it's kind of separation. We want to keep only the student information in student data, student relation, and the instructor information in instructor relation. Because of that, what if we want to combine those different source of data using the join operation? So join operation has the two relation with the join condition, like this. Also, we talk about there are different types of join, equi-join, and the theta join. Theta join is any condition. And also we have seen the natural join. Natural join will use the join condition for the common attribute, which is not very popular. So also we have seen the statistical function, aggregate function. So we can have the grouping factor, like for example DNO, and the average and this relation. So it will use the group by. So we can get the statistical information regarding to the group. Okay, these are the quick summary of what we have learned the last time. One more thing for the join the operation. So let's see that we have the student. So ID and name. So ID is 1, 2, and name is A and B. C. And there are the course, registration. So here are registration information and course ID and the student ID and course ID and student ID and registration information. So for example, the two student ID and course ID is 1, 1. This is not yes. The student and something Ollie. So student ID 2, 3, 4, and their course. So CS, database, OS, and the big data. Okay. So we have the two relations. We'd like to join the two tables to retrieve the student name with the course information. So what we can do is from student, we can join with RA, the relation with the ID is equal to SID. So then we can get all the attributes. So what will be the output of this one? So we can join ID, name, student ID, and the course. So from all the combination, we'd like to get the only ID equal to SID, which means 2, 2, 3, 3. So ID is a 2, name is a B, SID is 2, so D. And the 3, and it's a 3C and 3 4S. Only 2 tuples will be returned, right? So there might be no problem. However, what if you are asked, I'd like to retrieve, list all students, if the student is working for the as the array, the return the database and the course name. Otherwise, just the name only. Which means we will get all the information. That makes sense. Sometimes I wanna see the list of employee, all employee, their department name. Some of the employee may not working. They do not have information. So if because of that, we cannot see the name of employee from the list. But I want to see all the student name, all the employee name, all this the left-hand side, the table. So which means in this case what we want is ID, name, SID, course. So that one, A. Even though it's not matched, non-matched one return null and null. Okay? So that makes sense. So I want to see the kind of status of the old student. So if you want such a result from the join, at this time we can use the outer join. So this is called the left outer join. So left outer join means we will get all the list of left hand side. Then join with the right hand side relation. So if join condition is matched like this one, return the match the information. Otherwise, if not matched, it's not the following the condition. There's no matched one, just null information like this. So this is called left outer join. So left outer join symbol is from the join. You can use the additional line to cover the left hand side. Similarly, we can do the right outer join. So right outer join means so instead of the left hand side value, we can get the all value from right hand side. Big data. If there's no student information about this, it's just a none. None like this. Okay. This is called the right outer join. Symbol is like this. Which means, so we will keep the all right hand side relation. If matched, we can return the match information. Otherwise, if not matched, we can put the null data. It's the right outer join. Then, what if I'd like to keep the both left and right? Okay. If matched like this. If not matched, 1, 8, null, null. Null, null, 4, 8. Okay. This is called by combining this full outer join. So full outer join symbol is like this, both sides. So this, the outer join will be very useful for reporting tool. So when you generate such a reporting, so you can use. Otherwise, you can join. Then later you can run another query and combine. Instead, you can use such a outer join. Later, database, the SQL. So most of DBMS actually implement such a the left outer join, right outer join. Actually, right outer join is nothing special. It's the same as the left outer join, but you can just change it in order. Okay, so that is the most of the relational algebra operations. So we will see some of the relational algebra expression how we can create. So first, whenever you create the relational algebra expression, first you need to understand the meaning of the query. So query 1, for example, retrieve the name and address of all employees who work for the research department. If you do not understand the meaning of this the query, there's no way to create the relational algebra, no way to create the SQL. First, you should be able to understand. That's the same as what? The query that you define in your page 1 in English. So it's kind of translate into relational algebra expression. So after you understand the meaning of that, it's my rule. It's not general rule. But first thing you need to do is identify source of data, which means relation name or relation. So first, retrieve name and address. Where can you get the name and address of all employees? Employee. Then, who work for the research department? You can get the department number only from employee table. However, you cannot get the name of department from employer. Where can you get the name of department? Department. So identify the all source of data. Then check. Next thing you need to check is, in case the number of relation is bigger than 1, which means multiple relation, what is the way to combine 2 or more tables? Binary? What kind of binary operation? Mostly join. Okay? Most of these, the join operation is needed. At that time, you need to identify number of join. How many joins? So, this is a simple rule. It's not my rule. It's a kind of common sense. When you combine the two things, how many connectors do you need? 2 things. How many connectors? 1 connector. Because to connect. If you have the 3, how many connectors? 2. If you have n number of the relation, how many joins? n minus 1. So you need n minus 1, the join, what? Condition. You need to identify the condition. Join condition. So in this case, what will be the join? So employee has a DNO, right? That's the only information about the department. Then using the foreign key, there is a D number as a primary key of the department. So that is like this. Do you remember relational schema diagram? So we can use the DNO is equal to D number. Then using D number primary key, we can find the department name. So this will be join condition. How many? We have 2 tables, 2 relation, 2 minus 1, 1. So what if you identify the 5 relation from the first step? How many join condition? You need to have the 4. Okay, always n minus 1. However, even though if you do not identify, if you do not put the join condition, is it error or is it okay to use? There is no error. Why? If you forget the join condition, it will be what? Cartesian product. Cartesian product does not have a condition. So, which means Cartesian product is all combination. It's a really simple mistake. Happen a lot. You code a really nice SQL. It's really long to join the 10, 11 table. But if you forgot the 1 join condition in your SQL, it will run almost forever. Takes a really long time. That happens a lot. Really, it's a common mistake. So always identify this. The next thing is identify selection condition. Always you have the selection condition. In this case, what is the selection? It's like the filtering. What is the filtering? Who work for research department? It's the filtering. Not all employee the department information, only research department. So we can the research department as the selection condition. Then next, the project. We don't need the all attribute. Instead, name and address only. Sometimes this name is not the name of the attribute. You need to identify for F name, the MI, and the L name. And address is address, like that. Then that is the most suitable. Not always done, you need to other. Consider other operation, like whether we need the outer join, whether we need such the combination of the multiple, the set operation, and or whether we need the group by, so such the aggregate function. Okay, so these are the. It's mine. Just a suggestion. It's not good. So this is the standard way to find the your relational algebra expression. By following this one, there are two ways. One way is to write this one. One relational algebra expression. One no. Second approach is like this. You can decompose by the per operation. Either way is fine. So you can use this way, or let me show you the first example. It's not showing this. So, for example, in this case, so we can start with the two relation like this. How many join condition? One join condition. We need to join. And what is the join condition? That is the DNO is equal to D number. In case of conflict name, same name, you can use dot notation. Employee.dno, the department.dno. In this case, you can identify different name. So this is the join. Then you can apply the selection. Selection is D name is equal to research. Right? But we need only name, first name, middle name initial, last name, and address. This is the final result. That is the same as this one. Okay? So let's go back to here. We apply the selection first. Selection first. It doesn't matter. Right? As we have seen, it's a commutative, we can change the order. So this one, in terms of output, this one and this one is the same, but in terms of performance, it is different. Why? We will see later. Okay, so we will see query optimization. So, but in terms of output, it's the same, but the performance are different. Then the join with the D number and the DNO. So employee DNO. Okay, then the first name, last name, address, first name, last name, address as a project. So either way is fine. Okay. However, if you are using this notation, you need to use the research DPT as the name of the relation. Okay. So that is the first example. Second example is also sometimes SQL and relational algebra ask your creativity. Not just the logical way, sometimes you need something kind of creativity. So for example, this one. Retrieve the name of employee who have no dependent. Can you understand the meaning of this query? So I need the list of employees. So no dependent. So like I do not marry, I do not have any child, so only the single. Okay? That is the what we want. So due to that, how can we get such a data? There are different ways. actually to get this one. You need to join one. But think about we have the employee. If we know among the employees, some of them are single, some of them have the what? Dependent. If we take out the dependent, who have the dependent from the employee, then this one will be our result. So we can use minus, difference. How can we get? So for example, we will get the social security number, employee. We will get the social security number from the dependent. So this one has the employee who have the dependent. This one is the employee who do not have a dependent, the minus. Then join with the employee one, because we need the name and the first name, last name, because this one has only social security number. So that's another way to solve the problem. So sometimes some of the student or some of the employee, developer, they are very good. Even without considering this one, the directly SQL, because it's kind of different from the other program language. Okay? It's a structure. If you understand such a ER diagram and relational schema that design in your mind, then it may be much easier to create such a relational algebra expression or relational expression. We will practice more during the exercise lab. If you take a look at the textbook is free to rent at UB. So there are 30, 40 examples of such a query. Also, we will see some of the relational algebra expression while we are doing SQL. But it's also good practice. If you understand the relational algebra and relational algebra expression, SQL itself is just kind of converting, the translate. So this one is more useful to learn the SQL. One more thing. We talk about the relational algebra so far. When Dr. Yep could propose such the relational algebra, he also proposed relational calculus. So relational calculus is a different way of accessing the data. If we go back to the elementary school again, so when we talk about the set notation, there are different ways of this is a natural number, right? 1, 2, 3, comma, dot, 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 to represent the infinite number. Or we learned about x bar x, and if bigger than 0, and x is whole number. Do you remember? They are the same, different notation. So it's a very popular question. Which one is the same as which one? Like this. Relational algebra expression is kind of the focusing on this one. On the other hand, relational calculus focus on this is the conditional statement. Condition. The reason is that later, when we talk about the SQL is a select from where? Some of the students already mentioned about. What is the main part? Where part. Where keep the join condition and the selection condition, join condition, selection condition. The other projection and the from is not the critical. So why not focusing on the where condition? So relational calculus focus on the such a condition part. So T bar then give the condition of T. We can exactly the copy condition to the where condition later. So for example, this is the first name and last name of what? The bar condition. And the T salary is bigger than 50K. This is you can copy this part to the where later. However, this the notation relational calculus, if you know the condition, simple, it's done. However, it doesn't show actually step by step. If you take a look at this one, we first access this, the filtering, join, and the return projection. So later, when query optimizer the process your query. Query optimizer decompose your query based on relational algebra operation. So that's the reason I emphasize on relational algebra and however relational calculus. If you know the condition, you can use it for the SQL. So that is the condition and that is the relational calculus. Dr. E.F. Code actually when he proposed, he focused on the emphasize on relational calculus. So to access the data, we need to define condition. However, later we are going to use a relational algebra operation for query optimization. That's the reason we spend more time to know about the relational algebra expression. Okay, so you don't have to worry about too much relational calculus. Okay. Then finally, we can have the select from web. Okay. There are different ways of accessing the data. Like the query by example, but we don't have to worry about too much. There's an exercise. I'm not going to assign the homework this one for your practice. I'm going to ask the 1 or 2 questions from here for your midterm exam later. But please start with this. It's not that simple, but it's based on the company database. So, like for example, list the name of all employees in department number 5 who work for then the 10 hours per week on the product X project. Just hint, source of data. Where can you get the name of employees? So we need the employee. And in department number 5, 5 is already in employee. So we don't have to access the department right now. Who work more than 10 hours per week on the product X project? Do we need to access the department or not? In this case, not. However, if this question is a department, the IT department, we need to access. Here, we have the foreign key between employee and project. Works on hours, number of hours. So at that time, we don't have. However, in the relational schema diagram, where can you get the 10 hours? Works on table. So you need to access 3 relations. Employee, we have employee, and we have a project. We create the many-to-many. This is works on hours, right? We convert this one into what? Relational schema diagram. This one and this one like this. So this is works on. So we need to access how many tables? 3 relations, 3 tables. Employee, project, and works on. Number of hours. Then, how many join? 2, 3 minus 1. 2 join. So what is the join condition? SSN, ESSN. And project P number and PNO. So 2 join condition. And any filtering selection condition? DNO is equal to 5. And number of hours is 10. Okay, and project name is product X. 3 the selection condition. 3 selection condition, 2 join condition. So total where has 5 the condition. Then finally project. Project for name, first name, last name, that's it. Then you can create a relational algebra expression. Eventually that will be SQL. Okay, so you can, some of them are simple, but not always simple. Not like this. Sometimes you need to use this kind of the notation operation or so. So practice. You don't have to submit, but for your practice. Okay. Then 1 minute. Finally, we are going to talk about the SQL. SQL is the what? It's a language. It's actually implementation of relational algebra expression. Okay? So when Dr. E.F. Code proposed the relational model, he didn't mention about the SQL. Instead, he provided a way to access the relation. That is a relational algebra and relational calculus. Then later, some of the people, like the Oracle, who is the CEO of Oracle, Larry? He actually got the idea. So the model is really good to manage the data. So he implement. Then make the software. At that time, for the accessing method, what about the filtering? Filtering is a function, and the join is a function. So he actually implemented this idea. That is the SQL. So SQL is not the brand new language. It's actually the implementation of the relational algebra expression. So it's better later when you understand the query optimization, query processing. Using the relational algebra expression is much easier. So next week, the Monday, we will cover the SQL part. The Wednesday, the whole day, whole class, we will practice the SQL. At that time, you should be ready, either GCP or AWS, the MySQL. Okay? And also, you should be able to access them. Please practice the client. So last the exercise lab, we able to access the MySQL database using the client. So if we need it, if you are using the macOS, MacBook, you don't have to. It's already. I think you need to create. You need to install. Anyone who use the macOS? So you need to install the MySQL client. Otherwise, the Windows definitely you need to install the MySQL. Otherwise, if you are using the Chromebook, you can log on the GCP console, then using the G-Cloud, the SQL command, you can connect the database. Okay, so we will see on Monday and continue the SQL part. Okay, any questions?
When will be the midterms?
Midterm, after we complete the database programming, that will be probably, I guess, so can you see the October? So today is the 6th. So next week is the midterm exam, right?
It's on 2021.
This is a midterm. I think probably 25 or 27 we will have the midterm exam. So we need a couple of weeks more to cover the SQL and
2021.
what? So today is October 2nd. Then this is a midterm week, right? 14, 16, so 21 or 23. So we will have a midterm exam. But first we need to cover up to the database programming part.
Is 14th holiday? 14th, October 14th?
October,
14th.
we have a class.
We have a break of 14 and on 14 and 15.
It's a Columbus Day.
The
Same week.
only holiday is a federal holiday. So Labor Day and Martin Luther King Day, those are only the holiday, so we off. Otherwise, we have class. But October 15th, we have the faculty research, the development day. So up to, I think, 4 o'clock, all class will be canceled, but does not affect our schedule because it's Tuesday. And one more thing, last thing. So I almost.
So what about Monday, sir?
Which one? Yeah, 14 is the Monday, but we have a class. Columbus Day is not the holiday at college. So one more thing is the announcement, Engineering 400. As you know, I'm organizing the Engineering 400 this semester. Tomorrow, I'm going to invite Dr. Jehovah from the Clement college, so which is one of the top the liberal arts school in United States, and he is the director of the Data Analytics Center for undergraduate students. So this school offers the Data Analytics Center for students, those who are interested in the data analysis. So this is kind of the good opportunity how such a liberal art is doing the data analytics. So even though you are not registered in this class, I invite you, if you attend any the presentation in the Engineering 400 curriculum in this semester, I will give the extra point. So this is the 4:30 to 5:45, the tomorrow, Thursday, at the Tech 116. You know the Tech 116. So don't forget, sign in. There is attendance slip. So then I will give the extra point. Okay. Please use this one as an extra point. Any question? Okay, so we will see you on Monday.